Hello, everybody. My name is Mike Azarin. I'm joined by Haleh Fotowat. Haleh, would you like to introduce yourself?
Yeah, sure. I'm Haleh Fotowat. I'm a senior scientist at the Wyss Institute at Harvard University.
And so you have published a lot of art of the extracellular matrix and other neuroscientific and biological structures. What is that about?
So, yeah, so my art is kind of not intentionally trying to capture any of my science. So, I've been doing abstract art for a while. I just enjoy doing that. I find it, I this is something I do outside of science, and I feel like it's more free and completely spontaneously generated. And um, it's just more recently that I realized, just unintentionally, some of the elements of my work is showing up in in these paintings. For example, I um, have been looking at a lot of images of cells under the microscope, and then I find myself, because I draw spontaneous drawings, that's kind of what's really interested me to understand, like how spontaneous movements come across. And you'll see that in my fascination with trajectories in general of animals. And for art, I kind of let my hand do spontaneous movements. And I realized, why do I always keep wanting to do the circles? Like I never was doing circles so much. And then I thought, oh, it might be because I'm looking at a lot of cells that are circular under the microscope. So I know there's some artists that want to like bring biology into their art, but this, for me, this is kind of, is not really intentional, but I feel like subconsciously it is getting. And then once I realized that, I was like, okay, I give names to them like that. But
It's
it
kind of
was
like jazz.
exactly. And actually, really, a lot of times I do listen to jazz music when I do paintings.
Hmm. What and then so like what is your like creative process? You listen to jazz and like what is that you just like start drawing or how do you get I guess going?
Yeah, I kind of, yeah, I listen to a lot of improvised kind of avant-garde jazz music. And I go hear a lot of those kinds of live music in general. But yeah, listening, and then my paintings start usually with a drawing, with a pencil drawing or a pen drawing that is kind of my arm moving spontaneously on different surfaces. And then afterwards, initially, like a while ago, I used to like look at the drawing and be like, oh, what do I see in this? And try to bring that out. Some of my older work is seeing animals inside these spontaneous drawings. But then more recently is more has to do with colors and juxtaposition of forms and layers that come afterwards, which are all completely unplanned.
You keep using this word spontaneous and you're a neuroscientist. So I'm very curious like what does this word mean like in a neuroscientific context? Like does our brain do like spontaneous like truly like random activity?
Hmm. Yeah, that's a good question. Um, if you look at like the single, let's say, neuron, individual neurons in the brain, this term is used a lot, spontaneous activity, meaning that there is no stimulus, especially, let's say, for a sensory neuron, that, let's say, would respond to sound. You would have this neuron kind of fires action potentials in a seemingly random manner, but you can model that to see, okay, what kind of statistical, let's say, is it a Bayesian process or something? But um, let's say for now, random. And then once a stimulus comes, then it would respond. Its activity usually would increase or decrease in a time locked manner to the stimulus. But when there's no stimulus, it's kind of spontaneous, and that's what I refer to. And that happens. It's not just sensory neurons; all the neurons in the brain are usually, most of them, are not completely silent. They have some activity, even if um, they're not seemingly stimulated. So that's what I mean is like if I reach to grab a glass of water, there's a pattern of neural activity that is predictable, you would say, to go and grab this. But if I don't plan it or consciously, and it's not a good word maybe, but if I'm not specifically planning to go from point A to B on canvas, uh, but I feel like I let my hand go wherever it's going, which is a combination of the music I'm listening to or where I started, or if my arm hurts. I think everything has a previous history, right? So it's not completely random.
S-
Yeah,
So what's going on in your brain when you're drawing?
I don't know. I wish I knew.
You don't know? Well, if you were to guess, like, because I spoke with I don't know if you know Anders Sandberg.
Mhm.
He's a computational neuroscientist, and he was talking about how when he did LSD, he was noticing like the different um like visual or like tactile features. He's like, oh, that's a Turing pattern in my somatosensory
Hmm,
cortex. So I wonder if
interesting.
you have any similar thoughts, like when you're doing art, like, oh yeah, that's like this part of the brain, like doing that.
Yeah, I haven't really. I think the part of art that I enjoy is to not kind of try to logically analyze what's in my
Hmm.
brain. I'm sure there is some an explanation of why I, did this line like this, but I'm just not interested in that so much. I'm more interested in like the physical aspect of the painting, and I don't know, like sometimes it's usually after the fact that I analyze the painting and I'm like, what was going on in my head?
Yeah.
That I pick these colors and then I come up with explanations. Like I say, oh, here I have a painting that has two main colors in it. I have a giant black spot in the middle. Start with the black, and then it looks like a black hole kind of thing. And then on the side, there's this pink, and I don't know why I picked those when I was doing that. Afterwards, I said, oh, okay, yeah, I was looking at this object that like last week that had exactly this color. So maybe that's what kind of got into this. And then this black area is like, had all these dark things going on, and black was the first thing I went to. So I don't do it right when I start. It's just a feeling. It's like I want to start with this, and it's a lot of times there's a lot of energy involved in these paintings, and I don't sit down and think so much while I'm doing it. But then afterwards, I sit and analyze kind of at a higher level what because it's intriguing because it's like, okay,
Yeah.
I want to understand what was going on in my head. And a lot of times, as I said, like the circles and whatnot, that's my explanation, but I don't know if it's true.
Hmm. Do you think that like what proportion of the time do you think your explanations are like right? Like, do you ever realize like, oh wait, there's like it's like you have one explanation and then you realize like that's not it, and then you like
Yeah,
switch it?
I don't think I have had that experience of switching.
The reason I ask is because I'm very curious what the relationship is between your art and your science. Like, how did
Mhm.
you go from, I guess, doing visual arts in like Iran to then what, like studying what was it, electrical engineering at in Texas, and then going to like neuroscience? Like, what was that
Yeah,
like trajectory?
yeah,
To borrow your obsession.
yeah. I feel like it wasn't exactly in that order, so I can tell you, um, when I was in, let's say, in high school. Like I actually in Iran, I was not doing a lot of visual arts. When
Hmm.
I was in Iran, I was playing a lot of music. So I was really, I playing this Iranian instrument called the qanun. And, through like, middle school and high school and college, I was very seriously playing in bands and big orchestras and spending a lot of time playing music, which is also kind of an abstract thing. Um, and then at the same time in school, I was really interested in music, but I don't know, it's like also interested in math and logic and physics. So that's why I went into the undergraduate program studying electrical engineering in Iran and while doing music. So this was kind of music and physics, math, engineering was my track. And I actually didn't like biology so much. My parents were both biologists, but I was really not into that. I was more into math and physics and music. But in that culturally in Iran, it's like, okay, you do music, but that's a hobby. So it's not, art is not something you make a living out of. So if you like two things the same, then you go towards away from arts, which is unfortunate. But anyway, so then for my master's, I came to the US and still continued engineering. I had gotten into towards the end of my undergrad, I got interested in neural networks and artificial intelligence, its own version many, many years ago. So I wanted to continue that. And I moved to the US for my master's, still electrical engineering, did this master's work looking at neural networks, modeling the visual parts of the visual system elements. And then I realized as an engineer, I'm just looking at this kind of working with some kind of a black box where I say, this is the input, this is the output. We think what the neural networks that negate this are doing. But that had nothing to do with actually the brain is doing in my mind. And I didn't understand the brain at all. Like I had no biology background or anything. So at that point, I got interested in understanding the brain. And then that led me going and pursuing my PhD in neuroscience. And all this time I was still playing music. So even after when I came to the US, I was playing a lot of music. I was in a band. We performed pretty often. And then and for my postdoc, then I moved to Canada, working on weakly electric fish, which I can tell you if you're interested. It's a really cool fish that communicates and navigates using electric fields. And there, somehow, music didn't pan out for various reasons. Like I didn't meet the right people that would work with. My instrument kept breaking, so it was really hard times. And for me, I always had this art aspect that I was doing in parallel, and my brain could not function without doing both. So at some point, I switched to more seriously pursuing visual arts. So that's when I started, like 10, 12 years ago, doing more visual arts. Yeah, so that's how the
And then
transition.
what was the switch from music to visual arts?
What was it? What do you mean?
Like how did that happen?
Yeah, I did, like when I was in Iran, I also had taken some painting class. I was interested in painting before. I just didn't have time to do both music and painting. So it was pretty kind of natural. I used to draw all the time and doodle and do things like that. So kind of started actually, yeah, I can tell you a story. Yeah, it's actually funny. That's how it became more serious for me. I was doing um, I was a visiting researcher in the University of Maryland in Baltimore, or was it in Baltimore? Yeah, I don't know which one it was, but in Baltimore. I was there for 3 months, collaborating with the lab there. And then I was staying at this place and taking the shuttle to go to the university in the mornings, every morning. And it was super bumpy, the shuttle, like the road, I don't know where it was. I couldn't do anything on that shuttle. I was bored. So I had a little piece of paper or a little painting notebook with me, and I would make drawings, kind of let my hand go, and then the bumps would make the drawings. So every time I got a different pattern. And then I come home and then do watercolor painting on those. So that's kind of how it started. It was fun. Just to look at what patterns, what kind of trajectories, again, would I draw? This is not totally spontaneous. It's kind of driven by the road or bumps, but still not from me. It's from the outside. So I was interested in that, and that's how I started. I kept going, and I did bigger pieces and more abstract stuff.
And then how did you become interested in trajectories?
I don't know. I feel like I've always been interested in that since I was a kid. It's like, why do you take a certain path to go from point A to point B? Um, and studying, like, my studies in neuroscience always has involved tracking animal position over time in response to sensory stimuli or just normally walking around. And um, yeah, it's kind of a little bit mysterious, like why would you go this way versus that way? And I can't explain, but for a long time I've been there. And visually also I find it interesting. Um, just to look at paths of, let's say, animal migration and animal movements. Yeah.
I, w- I want to talk a little bit more about the spontaneity in neurons.
Hmm.
So you said that like what is the process of like and why might a sensory neuron like generate its own activity without a stimuli? Like what does that look like and what does that mean?
Yeah, that's interesting. And that's really fascinating area of research, which is not my area of expertise. But what's really interesting is that um, I think there are studies out there that looked at that you need this spontaneous activity in order to keep sensitivity in the like neck layers to somehow be ready. So for whenever the stimulus comes. So for example, um, as we are talking, your eyes would make this little saccadic movements. And then that little saccadic movement again could cause the spontaneous firing of your retinal cells. And then if you take that away, all of a sudden the whole world becomes blurry. So kind of that is part of the activity that is necessary to um, for perception to happen. Um, But I could also imagine another kind of system that didn't need to have that. But I feel like for the brain, this is an important aspect, which I'm sure if you talk to someone else, they can tell you a lot more about this.
Yeah, I was asking because of the spontaneity in your art and that you're also a neuroscientist. I wasn't sure.
Yeah.
Could you tell us a little bit about your area of research? Like I'm curious about the
Mhm.
fish.
Yeah. So you mean I've worked at some to make
The electric
electric fish. Okay. So that was my first postdoc research, which was I did it when I was in Canada. How did I get interested in that? So I did my PhD studying locusts' escape behavior, and I show them different kind of stimuli, and then they generate, and then recording brain activity while the animals escaped, and try to understand what is different when you jump and you don't jump. And it's really interesting. Like it's not that there's no activity in the locust brain when they don't respond to the stimulus. There's a bunch of activity, and so that was kind of what I studied during my PhD. And then I was interested in what's really brings about this variability in brain activity, which then results in differences in behavior. And I thought weakly electric fish were really cool. Like from my engineering background, I had an interest in understanding electric fields and electromagnetic systems. And these fish have an electric organ in their tails that generates electricity, and then they're in the water. Um, they're usually in these waters that are pretty murky, so they don't see so much. So they use the electric field and its variations. They have receptors all over their skin that detect these changes in electric field. They also communicate with each other using this electric field. And there's a lot of research that was done in their communication behavior and how neuromodulators change that, specifically serotonin. But nobody had looked at, in vivo, like in real time in live fish, how serotonin levels are modulated and how that would correlate with the ongoing behavior of the animal. So that's how I kind of went into um, studying the electric fish for my, yeah, for,
And so what is the effect of serotonin on their communication?
yeah, it was interesting because I thought the most interesting finding out of that was um, the, uh, what was I gonna say? Yeah, so the ongoing, so the behavior of the animal uh, affected their serotonin release, and that affected their response. It was like a feedback loop. So in kind of more aggressive fish, they have in general lower serotonin levels, but then being generating those aggressive calls like would bring it even lower, which would then make them more aggressive, which would, yeah. So it was very interesting to see kind of these types of correlations and feedback loops. It was kind of a while ago, so I don't remember exactly the
Hmm.
figures, but the overall finding was that um, the serotonin, the behavior of the animal, ongoing behavior of the animal, affects the serotonin release, which then affects the upcoming behavior, which would then affect the release of serotonin. So it's a very complex process, but that was a
Hmm.
little glimpse into that for me.
So it's kind of like a chicken and egg like
Exactly.
situation.
Yeah.
Wow. It's so interesting because I feel like we usually think of serotonin as like this like human chemical, like it's part
Mhm.
of like the human brain, but like I don't really think of it as something that like other animals like use. And I wonder like how their experience of like serotonin induced like feelings or like appetite like differs from ours, or like is there a difference between how like different animals use serotonin? Like what is that range of?
Yeah. It's a really interesting question. And I think what was very exciting, um, that so a whole range of animals use serotonin is really widespread and has all these different places where it acts, like in the gut and in the brain, and you'll like find it everywhere, and it does different things. But it's found across animals, and what was really interesting, like you would think of serotonin and neurons, but it's not even only in neurons. So there's like the biobots, that's my recent work, just the skin cells. There are specific cell types on the skin that secrete serotonin. And then there are receptors on the next non-neuronal cells that respond to that. So it is definitely not only in humans, and not even only in brain cells that or neurons in general that you'll find that kind of signaling.
What things can it do in other animals, and why might we expect to find it like not just in the brain but also in the gut?
It's a signaling molecule, right? It's something that is released to communicate, released from one cell to communicate to another cell. And it's nothing really special about serotonin in a way. It's like a way of cells communicating to each other.
So like what we have as serotonin, it's just like an art like the geometry or like the of the signaling molecules doesn't matter. Like what we have as serotonin could have very well been like dopamine, but like we just okay.
Yeah.
So is there any impact on like the shape of a molecule and um its signaling ability? Like is it really completely arbitrary?
No, I mean, it's so the serotonin molecule looks different from a dopamine molecule. And then, let's say within the brain, the neurons that respond to serotonin, that's kind of that they express specific protein receptors that would respond only to serotonin binding to them, like serotonergic receptors don't generally respond to dopamine molecules. They respond to serotonin. So there's specificity in the circuit. And then in the course of evolution, like why serotonin is being used in this type of circuit and dopamine is more common in other types of circuits. That's something that is an interesting question, and we would have to look back in the course of evolution, um, why why that is the case. But um, in general, they're not like right now today, you can't be like, okay, I want to completely switch serotonin and dopamine in the brain. That's not going to
Yeah.
work.
Yeah, of course. What is like the simplest organism that uses like serotonin or dopamine as like a
It's a good
signaling molecule?
question. I don't know. I don't know if you've like what's the earliest, most primitive animal in which these molecules have been found. Yeah, I don't know that, but I
Interesting.
imagine it should be very old, and for sure you see it in non-neuronal cells as well. So you don't have to for the organism. It doesn't even have to. I'm not even sure. Maybe you could look up, like, do
Yeah,
plants.
I'll Google it. Hold on.
Maybe.
Smallest organ.
Yeah, it doesn't. I don't know if it even has to be an animal.
Um, smallest organism that uses
Maybe say that
neuro
most primitive, not smallest.
most primitive
Yeah.
organism that uses serotonin.
Hmm.
Um, Coelen. I'm gonna put it in the chat because I'm
Okay.
not even gonna try to pronounce it. Oh, I guess like Coelen
Let's see.
jellyfish, sea
Oh
anemones,
yeah.
sea pens,
Uh-huh.
corals, true jellies, sea anemones, sea
Yeah.
pens.
Yeah. Yeah. So it's
S-
pretty
s-
old.
So do you know like what do those organisms use? Like, have you done any research on these types of organisms?
No, I have not, but they're
Oh, okay.
definitely very cool and interesting systems to
So
study.
what kind of research are you working on like now?
So right now, um, I so the Neurobots project is something that I've been working on most recently at the Wyss Institute, and hoping to continue that work. So with the paper that just got published. And there's another project that's right now I'm working on, which is not related to neurobots, completely different, which has to do with um, discovering novel types of drugs for general anesthesia. And this is like a big project that is across multiple institutions and labs that use different animal models and different approaches to study this. And those are kind of, we have some kind of new drugs that kind of pharmacologically induce a hibernation like state. And we're trying to understand whether we can use that kind of state as to like to use that kind of torpor like state as a state of general anesthesia.
Hmm.
So that's the other project that I'm actively working on.
Something interesting about anesthesia, and I was just thinking about this. Like anesthesia um quiets down or shuts down the default mode network, right? Like your
Mhm.
for people who don't know, it's like what it sounds like, the
Right.
network that's in charge of your default mode when you're
Mhm.
bored, when you're daydreaming. Um but so do psychedelics. And it seems that like anesthetics are like kind of like the opposite of psychedelics in some sense in terms of their effects and pharmacologically, but and phenomenologically, sorry. Um, but they both do that. They both have that thing in common. So like, what does that
Mm.
like mean? I guess.
That's a really good question, and I don't think I have a good answer for you. But there is something. So the way we're looking at anesthesia is very kind of in a standard, more clinical metric approach of looking and seeing whether in an animal model, so we're not testing humans at this point, but in an animal model, we need for general anesthesia for the animals to be completely immobile, to not respond to pain, and to not respond to a sensory stimulus, and they need to recover from that and not remember what happened. And what we're trying to understand is at various levels, but in terms of the brain activity, we're just starting to understand what do these anesthetics do to the brain, like how, um, let's say if this, as you say, if the default mode network disappears, how does that happen? And it's very interesting because different anesthetics do different things to your brain, and sometimes like for also ketamine is used as general anesthesia at some point. So at different doses, it might have different effects. Like at some point you have all of this, like whatever hallucinations and things like that, but then at a different dose, you might enter a different state. But exactly how these things are related, I don't think it's fully understood. And we're trying to kind of get at that. So there's a group that we're collaborating with, the lab of Florian Engert. This is where I was. They did another postdoc before joining the Wyss. They are using 2-photon and light sheet calcium imaging to look at zebrafish larvae brain. They can measure the activity of hundreds of thousands of neurons while they're being treated with different, in this case, anesthetics. But if you're interested, there's also another paper with ketamine and lower dose that is kind of used usually for treating depression and things like that. But for general anesthesia, it's interesting. Like, they can look at different brain regions. Most of the brain regions are suppressed. Some brain regions are increased. So we're just starting to understand how these effects happen.
Hmm. I wonder if, because you can use ketamine at lower doses just induces like general hallucinations and like psychedelic effects, but at higher doses, um, it you can use that as an anesthetic, you said. I
Right.
wonder if the same is true for like DMT. Like, I feel like that'd be pretty interesting to see, but I don't know how ethical it is.
Yeah, I don't know.
And the ethics board would have a field day with that, so
Yeah.
um but yeah, so what do anesthetics do like in the brain, and what have you like found out, I guess, from your research?
Yeah. So these are all very fresh questions. And different anesthetics work differently. But for example, it's known that certain types of anesthetics would target specific channels and receptors in the brain. Like, for example, propofol would hit GABA A receptors, which generally um, produce an inhibitory effect on the brain activity. But then some other drug like dexmedetomidine, it acts on alpha adrenergic receptors and works on the locust coeruleus circuits, and then produces this state of like low consciousness. And also with general anesthesia, a lot of times different drugs are combined with one another. Like, some drug might completely knock you unconscious, but then you might still feel pain. So that has to be combined with like a painkiller type of drug. So it's really hard to say. Like, each anesthetic compound would act in a different way. But in terms of behavioral end results that anesthesiologists are looking for is kind of your losing consciousness and motor and pain response. But then at which level is it acting? Like, for example, one of the questions that we were trying to address is we have these novel compounds that when we treat, so at the Wyss we use frog embryos, tadpoles as our model, and we run a lot of behavioral assays to look and see if they respond to pain, if they move, all of this. And for responsiveness to pain, they don't seem to respond to pain. But always this question comes up: do they not respond to pain because they can't move and generate any kind of response, or is it that they actually don't feel any pain? Because these are two different things. And yeah, so then by going into the brain and looking at regions of the brain that process pain signal, you can get to this question: that's whether or not that activity is present in the brain when you give this kind of stimulus.
How would you even know, like, whether it's because they can't feel pain or because they're unconscious?
So that's exactly, like, I guess our best way to answer that is to look at the brain regions that are involved in perceiving pain, in feeling the pain in a way, and not just not responding, because these are different brain regions.
Do you have to like put them under an? Because like I feel like I got in surgery before,
Mm.
and it's like, how do they know like when they're giving me surgery that like I'm like actually fully knocked out? Do they like be like Micah, 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 wake up, wake up, wake up,
Yeah.
and then like
They have their own methods. I guess I don't know how anesthesiologists assess the depth of anesthesia, but I'm sure there are standard ways that they use to know, okay, what dose we should give. Should we give him more? Should we, but in terms of, and another thing that's really interesting, I'm curious to know when you underwent general anesthesia, do you have any memory of while they were doing surgery on you, or is it completely gone?
no, it's like I was so confused because it was like it was like it's not like when you go to bed and like you know you were sleeping.
Mhm.
And it's like, oh yeah, now it's morning. It's probably been like probably couple hours or
Yeah.
so. Probably because maybe it's because you have experience sleeping and you have that like habit of like maybe when I was a kid like and I woke up I was more prone to saying like, oh wow, it hasn't been any time at all.
Mhm.
When but even when I nap, like when I nap, I know that time has passed.
Yeah.
Um for with anesthesia, it's like it's not I don't have that knowledge that time has passed. It's like from my perspective, they just put me under anesthesia.
Hmm.
And that part of my memory, it's not blank, it's just like not there.
Mm-hmm. That's interesting. Yeah, that's another metric that of good general anesthetic drug is to get that effect, to not for you to have just complete blank and not
Yeah.
like but then yeah, there's some stories of I have never experienced that, but people saying, "Oh, I felt everything," or I didn't
Ooh.
feel pain, but I remember. So
Ooh.
that's pretty bad. So you want
Yeah.
to make sure that your drug is having that effect.
Is AI affecting your research at all?
Yeah, definitely. I think more and more. Yeah, I think as a tool, it's a very interesting tool to use for research for sure.
How do you use like large language models at all like in your like research for experimental design or
Yeah, I think me personally, not as much as a lot of other people that are more, their work is more focused on. So we have groups at the Wyss Institute that deal with a lot of large data from like multi-omic studies and patient data and a lot of work with a lot of databases. So I feel like they more actively use that. But in my case, I think it's been a really useful tool to kind of see what's out there, what's being done before on a certain area that I'm doing research on. So, like, for example, before I would go to PubMed and search all these papers, but now it's kind of a little easier, although still not always accurate. So a lot of times it's hallucinating and just
Mhm.
fitting out this paper that doesn't even exist. So you have to um, really be critical of it. Uh, so yeah, so basically, yeah, I've been using that to see what's known about X and Y in the field, and then going in there and say, "Oh, is this really real?" Checking, and then going to the papers, and uh, yeah, I think that's
Do you think the lack of like maybe before when you read papers like you were reading the whole thing or like more of it and so you'd really get like
yeah.
a deeper understanding of like what's going on. Do you think the depth of your understanding is less when you use like a large language model?
That's a really good question, and I feel like, um, as a student, like when I was reading papers, I was doing this, as you said, like I would spend a lot of time and reading every single thing and questioning every single word and going to every figure and dissecting it, and that's a really, really good training to have to train critical thinking and all that, and also experimental design. How do you design something? So it's very important. But I feel like as there are more and more papers, and even before AI, like as I, kind of as time passed, and there's so many papers, you really don't even have time to go that super, super deep on every single paper that comes out in
Yeah.
your own field. So you end up really needing, oh, I wish there was a good review paper if you were getting to a new field, or, oh, this paper is cool. I'm interested in this method that they use. So a lot of times I find myself that I'm not particularly interested to see how they got their specific results if it's not what I'm working on, but I'm just interested in their method. So I would just skip and go to their method section, or only read this part of it because there's not time. I do wish that, time would expand forever, so we would be able to spend time and read everything word by word, but that's the reality is it's not the case. And if
Mm.
you can use these tools to extract the information, specific information you're interested in, I think that's useful in that sense. But for
Interesting.
students, I think I still recommend those kind of rigorous reading and criticizing, all of that. Um,
So large language models are probably more useful when you already could do the task by yourself. Like for experts basically, it seems more useful.
I don't know if it's only for experts. Yeah, that's a good question. I feel like um, I'm not currently involved in working, like teaching a lot of classes to students. Um, that has really changed since I was a student. But talking to other people that are teaching in schools, they say, yeah, our ways of teaching has completely changed. For example, now you can use Claude or whatever to write a program for you to just do whatever you want it to do. Um, but the way they work in schools now is they are required to first write this program themselves and kind of go deep and be able to explain, or even have Claude do this, but you would have to still be able to explain the logic and why it's doing it like that and be able to do it. But then once you get past that point, it's fine to use those tools. It's kind of
Yeah.
like calculators.
Yeah.
Like you need to know the logic behind addition and subtraction, but there is no point of not using a calculator and doing everything by hand when you have a calculator.
I was looking at like the paper by Lebet or whatever on like the free will stuff,
Mm-hmm.
and I was like looking at it, and I was thinking like this is so stupid. Like the conclusion he's coming to clearly does like I feel like the conclusion he's coming to like could be explained by so many other things.
Mm-hmm.
And so I asked Claude like, is what I'm saying valid? And it was like, yeah, like you could read this paper and they said the same thing. And I was like, oh damn. Like it's so annoying. Every time I have a new idea, some guy in like the 90s came up with it first.
But that's really, yeah, I think it's very important to not use things, tools, whatever, in a passive way. I feel like being passive is the worst thing you can do to your brain. I feel like at some point, you kill all the noise that you could get out of, thinking about something, and all of a sudden getting aha moment like that. You're gonna miss all of that in your life, which is a terrible thing. And also, I don't know, I think we don't know the long-term effects of passive use of AI on brain health.
Yeah, I'm sure. Like my grandpa is like a ChatGPT addict, like
Really?
ChatGPT holic. It's crazy. It's crazy. He talks to it like 3 hours a day. But I mean, he does say he's a vet, but like he uses it to like dose,
Mhm,
like or like help like find dosages or like check certain things.
mhm, mhm.
But luckily he has the pro version, so
Yeah,
hopefully nothing
and I
nothing
think he'll be
happens to the
fine
animals.
most of his life. He is, and not use that. But if you start being like that since you were in high school or whatever, just
Yeah.
like being passive with your brain, I don't think that's gonna go well.
Yeah, I wrote this essay on my Substack, like Sleepwalkers, and it's about how like people like just kind of sleepwalk through their lives,
Mhm,
and then they don't realize until like literally like sometimes like the moment before they die that they've been just like sleepwalking. And I think more and more we're seeing that, and worse, like I said with the pro subscription, I think we're gonna see um like whether or not you can you passively or actively use ChatGPT will be gated by how much money you make.
mhm.
And so or whether you're even able to have access to the tools in the first place. is going to be gated by how much money you make, and that will make the wealth gap unfortunately even bigger.
Yeah.
So I don't know if they're going to do anything in the government. I hope they do,
Mhm.
but right now, you know, the current president, uh, the latest and greatest from the president of the United States doesn't seem so favorable. So we'll see. I guess we'll
Yeah.
see. Whatever. It's my future, but
Yeah. And it's
I
cool too. Like it's not just the US, like globally how all of this are dealt with. I feel like that's a whole other area that maybe is not getting enough attention, or maybe the progress of all these fields has been so fast that the regulations or whatnot, government regulations, or even research on brain health and all of that hasn't had time to catch up. So it might be that, it's kind of like they're definitely, so it's not all negative, of course, but it might take a few years to figure out, oh, this part we were doing wrong. Let's go back and hopefully the damages could be reversed. But I think it's inevitable that with everything. Um, brings the other point that there are a lot of worries about AI and what's going to happen in ChatGPT, but then already, what we should most more worry about that is very pressing right now are phones, right?
yeah,
It's
and
yeah,
the short form content specifically.
yeah, and like people are constantly on their phones and kind of disconnected from everything, and regardless of like all these AI stuff.
Yeah. So I think like we're probably a little bit cooked, but I don't know if we're like burnt. I think we're like probably mildly sautéed. Um,
Yeah.
I think I think that like especially like my like brother's generation, he's like 12.
Mhm.
Um they're still like kids who are curious about stuff.
Yeah.
Like my brother has this friend. He's like super smart, and I like tutor him in math, and I like do this like
Mhm.
cognitive enrichment tutoring thing.
Mhm.
And he like it's just as curious as like you know like me, I guess, I to
Yeah.
use a
Yeah.
an analogy, but I guess that comes out through him, like he has these conversations with ChatGPT, and he asks it like questions, and he asks it like like yeah, and so I think that's probably useful, but at the same time, I feel like they are missing like a certain like level of like wrestling with certain questions. Um,
Yeah, and I think we were having this conversation this morning with my former PI, that ChatGPT, AI, all that. What is missing in there is like there's no real kind of, they're not gonna completely disagree with you, or like there's no kind of aggressive or any kind of pushback from AI to you. And I
yeah,
think but in real life, when you're dealing with people, it's not the same. So you kind of want to have that experience too,
yeah,
growing up, and not only like dealing with your ChatGPT.
and there's Suno AI.
No.
It's like this thing where you can have it like make any song you want,
Okay.
and it does it really well. But my issue with it, is that like for me, I like and it will like you get to tell it songs you like, and it'll make a song like or like songs that are specifically tailored to you, and you'll
Mhm.
really enjoy them,
Mhm.
like because of like
Does
your
it
like
work?
it works really well.
Really? Okay.
The issue is that there's a certain social quality to music. And it's like, like I was not a big, Pink Floyd fan. My whole mentality was like, they take a long time to start singing.
Okay.
Like, I don't care. And then I was in the car with my friend who really likes Pink Floyd, and he was playing Shine On You Crazy Diamond.
Mhm.
And I was like, And I was just listening to it, and then I got it. Like I was like, wow, this is
Yeah.
really good.
Yeah.
And that social quality of like expanding your music taste and listening to with other people and listening to songs that are not 100% yours and getting someone else's experience
Yeah.
is so vital for my development, anybody's development, or even adults, just to be able to like
Yeah.
empathize with people and understand like other people's
And
situations.
also
That
going
is the
and
beauty of
hearing
music.
hearing live music too to bring it to a different level, I think.
Yeah, for sure.
Yeah.
And so when you have this software that can curate everything for you, it gives you like this individualistic outlook where it's like,
Mhm.
if you ask any artist, like who are your inspirations?
You mean for like my paintings?
Your paintings, your music?
Yeah, like Helen Frankenthaler is one that immediately comes to my mind. I'm for art, and I'm a big fan of Jonas Mekas. So he's like an avant-garde filmmaker. He was. Yeah, so I have my little heroes in every different
Yeah.
fields.
So I can tell you, like, I write poetry. Like,
Oh,
I could
cool.
tell you, like, I could list, like, my inspirations, like E. E. Cummings, Walt Whitman. Like,
Mhm.
I can, like, boom, boom, boom. Like,
Yeah.
and if you ask the people who use Suno, like, who were your inspirations?
Hmm.
They will not be able to tell you.
That's sad.
And I think that's what really makes it, like, that's one of the key distinctions between using Suno or using ChatGPT to generate, like, like an idea you had versus doing it yourself.
Yeah.
Other than all the other ones, that's I think the big one because being inspired, like, you know, I don't know if I could say that ChatGPT art isn't art because I do think it is art because if people say like, oh, it's just a remix of like other people's works. Well, like, yeah, what do you think your brain is doing, right? You're inspired by these things and you make something original based on your like, experiences in the world and through other people's art.
I think for music, there's another element of people physically playing an instrument, the
Mm,
art aspect of it, which is not like all the nuances and all the differences that come in every performance and has to do with that, which I don't think you can get. You definitely can't get it from some generated kind of music that
hmm
way.
Interesting. Do you think that AI visual art is still art?
I don't. I mean, so far I haven't seen any AI generated visual art that I've liked. I haven't been
Yeah, okay.
looking for a lot, but I think no. I think I don't know. For me, this kind of having a human element of unpredictability and kind of being influenced by your surroundings and all of those things. I think it's important in making a piece of art kind of more. Even like when I
Yeah,
look at two different real artists, uh, I enjoy one more than the other. And I feel like
yeah.
that has to do with their view of the world and their life and their philosophy and the way they see things. Like when I listen to artists speak, the way they talk about the world and how that comes into their work. I think that is something that you can't replicate, at least at the
Yeah, yeah, for sure. It's missing like that human quality, I think.
right.
And that makes it really like art and not just like there's a difference I think between, like ink and art, right?
Mhm.
Like ink on paper and art cuz like you could have a machine even if like if a machine did put like a bunch of ink on paper, I think it would not be art. It,
Yeah, and I think there's one point is you as an observer looking at art and saying you like it or not. And the other point is the artist. So
like
there's
if like
other
if
artists in this world to actually enjoy. I mean, this kind of goes back to the
yeah.
same thing of like, do you want to just do everything with ChatGPT, then you don't enjoy life as much, right? So, as a human
Yeah.
being, like you want to have a life that is full of experiences and joys that life can give you. And let's say if I do art because I literally, as a person, enjoy it, and selfishly, I want to keep doing it. So there's no replacement for me. Like I'm not gonna now all of a sudden use AI to do art for me because that takes away the joy of it from me.
For sure. Yeah. And like I would just like I'll give you an example. When ChatGPT first came out, I really love math. I have a math tattoo. Like I don't know
Cool.
if you saw it before.
Nice.
I show this in like every episode to everybody. Like it's
I
my
love math
my
too.
most
I agree. That
yeah
the math is really awesome.
yeah. I love math. I have like math textbooks over there, and over there. Like
Mhm.
you know, I'm a mathaholic,
Mhm.
and so when ChatGPT first came out, I had like this bout of depression because I thought like, damn, like I can't do math anymore because like this machine can do it for me. And so now
Mhm.
there's no need to like learn more math because I could just have, like and really struggle with it. And I was really sad. And then I realized like I don't care. Like I'll just get to it anyways. Cause I think that's really like what being human's about. Like just like
But also
the
all
math
these
it's
large language models, they're kind of based on, at best, based on what is known and done today. And
yeah,
it's
well to be
not
fair,
what happens, like, yeah, especially for with math, there's so much abstract concepts of I don't know what kind of math you're into that I think you can keep doing math forever.
yeah. Yeah, I think even if ChatGPT can like do certain pieces of math and like it can even if it can like prove completely novel theorems, we're the ones that want that ask it questions and guide it.
Mhm.
Um and like my fear is if it starts, if we have some agent like AI that can sort of ask its own questions and pursue its own interests.
Mhm. But that
That's
kind of could be another human being, right? People do this all the time. I mean, I'm not saying AI is human beings, but what about that scares you?
Well, because it's not just another human being with its own perspective, and like, it's something and like humans can only have like finitely much information,
Mhm.
and especially if everyone had their own like agent,
Mhm.
right? Like, it's like you lose, I think, a lot of like the desire to do it yourself.
Mhm.
And there seems to be like, if this thing can do whatever, like, well, I guess then it wouldn't have its own interests if you're asking
Right.
it. Like, you would still have your own questions, and
Right.
maybe you could ask it, like, what do you think? But
Right.
then you may have your own solution, and then be like, what do you think about this solution?
Yeah.
And then it might say, like, oh, like, it's wrong because of this, or this, or this. And they say,
Yeah.
well, actually, like, this, and that,
Yeah.
right?
I mean,
Like,
it's
one
just
thing
kind of like the same thing. Like in the old days, there were
yeah.
books, right? You're like, oh, I have an idea. I go find this book and read it, and then see what other people thought, and then you're like, oh no, but then it's kind of a little bit the same. As long as you're doing
Yeah.
things actively and not just listening to whatever it tells you.
Yeah, I think activity is the big point. Like, and I think most people are sleepwalking. They're doing it passively.
Right.
It seems and it's very how would you know if you're sleepwalking,
Yeah, that's
right?
a good
Like
point.
the only way to
Mhm.
know is to like wake up. But like,
Yeah,
how do
wake
you
up.
know if you're woken up, right?
Yeah.
Um, and that's a big issue.
Mhm.
Um, okay. I was gonna say something really profound,
Mhm.
but I forgot. So just pretend I said something really
I
interesting.
think that you did already.
Oh, thank you.
Yeah.
Oh, here's what it was.
Okay.
Um, so I had this idea. Do you know the secretary problem?
No.
It's this problem in math and optimization where it's like, okay, let's say you're a guy and you're trying to find or I mean, it could be a girl, it's 2026, or even a non-binary person. You're
Mhm.
an individual human being and you're trying to find a secretary. And suppose you have like n options for like secretaries, and so you have at the first person you can either say this person's gonna be my secretary, you get their resume, and you either say this person's my secretary or no, and you reject them, and you'll never see them ever again.
Mhm.
There's no way to get them back. Then the second person, you could say this person's my secretary or no. So at what is like the optimal strategy for trying to find the best secretary in the
Mhm.
pool? Because
Mhm.
and it turns out that optimally, so the optimal solution is take the first 1/e%, so about 37%
Mhm.
of people, and
Mhm.
reject them.
Mhm.
Then the first person that's better than the first 37%, or
Mhm.
1/e
Mhm.
percent, um, take that person. The first person that's better than the first 1/e%,
Mhm.
37%. And so
Interesting.
I was like I was trying to go to sleep one night, and I was thinking like, all right. And I remember I read somewhere that like our like adult mortality rates for like humans in like the Paleolithic era are like are much higher than infant mortality rates because like once you make it past like 8 or so, or like 12, like you're
Mhm.
expected to live to, let's say, like 72.
Mhm.
Um,
Mhm.
and then but if when you're born, you're expected to only live to like 30 because of
Mhm.
how like averages work.
Mhm.
Okay, the prefrontal cortex finishes or slows down myelinating at 25, right?
Okay.
72 divided by 35 is almost exactly 1 over e. So
Okay.
what I was thinking
Yeah.
was like, or sorry, 35 over 72 is almost exactly 1 over e.
Mhm.
So what I was thinking is like maybe this is some sort of like secretary problem where it's like an explore to exploit ratio and evolution is like taking advantage of that. And
Mhm.
so I woke up and I was like, who can I email about this? And then I emailed Scott Aronson because I had him on, I don't know if you know him. He's like a
No.
quantum computing guy because I
Okay.
had him on my podcast at the time. And he was like, how would you even like falsify this? Like, how would you know?
Mhm.
And so I thought about it, and then I even like asked ChatGPT, and ChatGPT gave me something like, oh, compare cross species,
Okay.
like check like bonobos and stuff. And so the data on bonobos wasn't available.
Mhm.
So then I thought was like, what about crows?
Mhm.
Because crows don't have a prefrontal cortex. They have something analogous to a prefrontal
Okay.
cortex. So if the same pattern was true in crows, it would probably be some case of like convergent evolution, and we know that evolution could at least there is some mechanism
So
by
you
which it
mean
could
like the
happen.
the the point in time, the age at which the prefrontal cortex stopped myelinating?
Or it slows down myelinating
Stopped myelinating.
divided by the or the divided by the mortality rate,
Okay.
like the adult mortality rate
Like,
of
why do
like
you
let's say
think why would you think they would be related biologically?
well because like you think of like okay up until 25 like what are you doing like in nature or even like below that like you
Mhm.
spend the first bit of your life exploring, right?
Mhm.
Or in the secretary problem that would correspond to like looking at these first 37%
Mhm.
and gathering data about the world and like
Mhm.
being more creative. And then after 25, you stop myelinating, and that would correspond to the exploit
Mhm.
portion of the secretary problem. Okay,
Mhm.
now we have this first 37%. We have this information about
Mhm.
what's in the pool.
Mhm.
Now we can exploit it. Right
Mhm.
now, and
Mhm.
that which would correspond to the prefrontal cortex slowing down the myelination and like
But is it only I don't know this field, is it only the prefrontal cortex that slows down myelination, or are there other brain regions too?
I think brain develops back to front. So like the limbic system is like is it's not like it finishes myelinating.
Yeah.
It keeps myelinating through old age.
Yeah.
But like the architecture and like even to like 34, I think I remember seeing a
Mhm.
paper in
Mhm.
certain areas it's still but generally speaking, you see a big slowdown in myelination at 25.
Yeah.
So I don't know, like it could just be like a complete coincidence
Yeah.
which I suspect it may be, but I still think it's like,
That's
you
pretty
know,
cool. Yeah, for sure.
yeah.
Yeah. I think you
So
should pursue that for sure.
yeah, I wanna do something with like neuroscience, I think, but I'm
Mhm.
not 100%. So
Mhm.
we'll see. Sorry for that long
No, that was really
digression.
cool. I like that.
Thank you.
Yeah, it's
Thank you.
interesting. And now
Okay.
you wanna
Uh,
look at, do you think, like, crows, you were thinking, and then maybe, you can look at the mortality rates and, uh, other types of, like, insects or, in like, primitive animals that didn't have myelin.
yeah.
Like, how would
And
it
I saw that in certain apes and monkeys, like
Mhm,
I was able to find the data. The ratio was close to 0.37, but not exactly. It was a little bit lower. And
mhm,
then in rats, it was like much lower. So
mhm,
that could just mean that like rats are just using an inoptimal strategy if this is true. But
mhm.
you know,
Interesting. Very good questions.
oh. All right. Sorry, I'm low key. I have to go.
Yeah, me too.
I'm like 5 minutes late
Yeah,
for
yeah.
school.
Okay.
Um,
Yeah,
but
it was great chatting with you.
I need to ask one question. Do you have
Mhm.
any advice for me?
I think I the advice I give, was, like, to keep your brain active, and be curious and question things, but I think you're already doing that, I think.
Oh,
Pretty awesome.
thank you. I
Yeah.
appreciate you coming on.